All right, this video is covering 9.2, and it's confidence intervals when we're using the sample mean. So your point estimate for your sample mean is just X bar. So you've made your distribution of your mean, you find the X bar, it's just the sample mean. We already know that symbol. In case you can't remember how to find it, here's this table. The website fueleconomy.gov allows drivers to report the miles per gallon of their vehicle. The data in the table shows the reported mile per gallon for 16 owners. Obtain a point estimate. So we could add them all up and divide by 16, or we hit stat, edit, and type them in here. So we have 35.7. Oops. And 36. So I'm just going to double check that I entered them right. Okay, and then we do stat, over to calc, one variable stats, making sure your frequency list is blank. Oops, stat over to calc. And then hit enter. X bar at the top there, that's our point estimate. So for this one, X bar is 36.8. We already know how to do that. Okay, a different sample will likely give a different mean, just like with the proportions. So we report out in an interval. And if we think way back, in chapter 8, the mean stays the same, and then our standard deviation is the standard error, where we divide by the square root of n. Because we don't always know the population values, like standard deviation or such, a lot of times you're just given the information, you're not given the data. We're going to use what's called the t distribution instead of the z that we've been using. So this allows us to use statistics, even though we don't necessarily know all of the population values. Your t changes depending on your sample size, which we use the degrees of freedom. I don't know if you guys remember that, but it was n minus 1. And then it's still centered at 0 and symmetric, like z was. And then as n increases, t gets closer and closer to z. It approaches z. So the bigger the population, the closer to z it is, because we have a normal population. So there's a new table. It's called the t table. So it looks a lot like the z, except this time it's got a t on it. We're talking about the right side instead of the left side. And we have area in the right and degrees of freedom instead of a specific z-score. So if we are finding the t value so that the area to the right is 0.10 and 15 degrees of freedom. So we're looking for our degrees of freedom of 15, that's on the side. And then our area to the right is 0.10. Notice up here on the right. So those are just the things we're looking for on this table. So area in the right is 0.10. Degrees of freedom was 15. We find where they meet, and we get 1.341. All right, so that's how you use the table. When we're doing the left, it's the same thing, and remember it's symmetrical, so our t-score is just gonna be 0. So our values, area is 0.05 and 25 degrees of freedom. So we find 0.05, we find 25 degrees of freedom. So our t-score is 1.708 on the right. And the fact that it's to the left makes it negative. That's all. If the correct degrees of freedom is not listed, use the closest value. So let's say it was 82. Let's say our degrees of freedom was 82. Well, there is no 82, so we would just use 80. If you get over 1,000, then you're just going to use the z table instead, because as you see here, it approaches z. So those are your hints. Now, When we're finding confidence intervals involving the mean, we're going to use the t-table and the t-interval instead of the z-table and the z-interval. The biggest thing we need to know is if n has to be greater than 30 if we don't know about the population or if we know it's not normal. So if I tell you it's skewed, n has to be greater than normal. And then, like before, it has to be linear for our probability plot with no outliers if it were a box plot. Margin of error looks similar. It's that t-value times the standard deviation over the square root of n. Those are just some equations. So let's do it. Using the table above, find, that was the miles per gallon we just did, 95% confidence interval. So from the one variable stats, when we did that on the calculator, we found a mean of 36.8 and a standard deviation of 2.92. That's our SX because it's a sample. We know we're 95% confident, so to subtract 95, we have 5 degrees in our tails. For example, this is our curve. So we have 95% of the data here, meaning there's 5 on the outsides. So we have to divide that by 2, and we get 2.5% on each side of that 95%. So on our table, we're going to look for an area of 0.025. We had 16 cars, so our degrees of freedom is 14. So if we look on our table, 0.25, degrees of freedom of 14, we get 2.145. So let's double check that, 14.025, 2.145, all right? Then we would take our point estimate, which is 36.8, and we would add 2.145 times the standard deviation over the square root of 16 squared. And we would do the same thing by subtracting it. And remember, the 16 was how many cars were in our sample. So if I type that in the calculator, I get 38.356. If I type that in the calculator, I get 35.244, which means we are 95% confident that the real mean is between 35.244 and 38.356. Just like with the z-score, the calculator will do it. You want to, if you're given the raw data, so if you're given that information, you need to put your data in L1. Then, like before, we do stat. We arrow over to tests, but this time we're going to choose number 8, which is the t-interval. So we're talking about t-values, so this time we're going to do the t-interval. So I already entered the data for our information, so I can go over to tests, then I'm going to choose number 8, t-interval. And at the top, you pick data. Because we have the raw data in there, you pick data, and then make sure your frequency list is 1, your confidence level matches, and then calculate, and it gives us our range, 35.246 to 38.356, and there we go. Okay, so, and those match, so we're looking good. Now, in the t-interval, it will always be larger than the z because we're using estimates. We don't necessarily know the population, so it's always going to be bigger. Now, what do we do if we don't have the raw data? Well, a simple random sample of size n equals 30, so we know it's enough, is drawn from a population that's normal with a sample mean of 50 and a standard deviation of 8, conducted 98% confidence interval. So we're still going to go to our t-interval. So stat, arrow over to tests, choose number 8, the t-interval. But this time at the top, we're going to choose stats and hit enter. And now we know this information. So we have 50, we have 8 for our standard deviation, our n is 30, and we want to be 98% confident. Calculate, and we get 46.404 to 53.600. So there is that range there. X is 50, S is 8, 38. All right, there we go. And then just like before, we can also use this to figure out how many people we need to ask. It's okay to use Z for this part because T approaches Z. The Z table has them at the bottom, so it's okay to just use that. So how large a sample do I need to estimate the mean? Within 0.05 and 95% confident, here's our standard deviation. So 95% confident is at the bottom of that Z table, or here, so 95% confident is 0.025, so 1.960. So again, that 5%, if I divided 5 by 2, I'd have 2.5%. And then we go all the way down to the Z, 1.960. That's where I got that number. Then we want it to be within 0.5, and our standard deviation is 2.92. Type that in the calculator, we get 131.0. And remember, we always round up no matter what, so we're going to ask 132 people. That is section 9.2. Let me know if you have any questions.